Hello friends, welcome to our YouTube channel Age at Education Adda. In this lecture, we will discuss one important problem of mathematics. Before starting the discussion, I would like to tell you if you want to get more important problems, you can visit our website education-adda.com. Link of the website is also available in the description box of the video. So how you can get these questions on our website? So you need to visit education-adda.com, then go to menu option and select academics adda. In academics adda, you need to select math important questions. One more thing, all these important questions are available in the form of video lectures on our YouTube channel and the playlist is titled as Math Important Questions. Okay friends, so coming back to the given problem, what is given here? The mass of a radioactive substance follows a continuous exponential decay model. Okay, and what is given, further information is given. A sample of this radioactive substance has an initial mass, that is initial mass is given as 8.197 kg, and also it is given that mass decreases continuously at a relative rate of 16% per day. Okay, so mass of the radioactive substance is decaying and the rate is 16% per day, and we need to find the mass of the sample after 4 days, and also we need to find the exponential function for the given situation. Okay, so what we need to do, we do not need to round any intermediate computations and we have to round only the final answers, okay, to the nearest tenth. So see, initial mass is given as m naught equal to 8.197 kg. Also, it is given rate of decrease per day. It is r equal to 16%, that is 0.16. Okay, this is rate of decrease of the radioactive substance mass. So we are assuming that the decay function be mt. What mt denotes? See, mt is the mass which will be mass of the radioactive substance after t number of days. So mt equal to m0 into e to the power minus k into t. Okay, where k is a constant, or we can also call it as a decay constant. Okay, so we don't know the value of k, and from the given information we can find the value of k. So what is given, that mass decreases at a relative rate of 16% per day. Okay, so 16% per day is the relative rate, means if today mass is m0, then after one day it will be m0 minus 0.16 times of m0. Okay, so it will be m1, like after one day it will be m0 minus 0.16 m0. So it will be equal to, using exponential function we can write m0 into e to the power minus k into t. And what is t? T is one day, so we have written it as 1. So from this we can write 0.84 times m0 equal to m0 into e to the power minus k. Okay, therefore m0 will get cancelled out from both sides and we will get 0.84 equal to e raised to the power minus k. Now taking natural logarithm of both sides, see, here it is exponential function, so when we will take natural logarithm we will get ln of 0.84 equal to minus k times ln of e, and ln of e is equal to 1, therefore directly we have written as minus k, and from this k will be equal to minus ln of 0.84. Okay, now we have got the value of k. So substituting this value in equation 1, our decay function will be mt equal to m0 times e raised to the power, see, it was minus kt, so minus minus it will be plus, so ln of 0.84 times t. And as m0 is given as 8.197, m0 is the initial mass of the radioactive substance and it is given. Okay, so we can write mt equal to 8.197 times e raised to the power ln of 0.84 times t, and this will be in kg. Okay, now this is the exponential function. So exponential function for the given situation will be mt equal to 8.197 times e raised to the power ln of 0.84 times t. So we need to find what will be the mass of the sample after 4 days. So substituting t equal to 4, we can find the required mass. So substituting t equal to 4 in this equation, we will get m4. M4 denotes mass after 4 days. Okay. So it will be equal to 8.197 into e raised to the power ln of 0.84, and in place of t we need to substitute 4. So after calculating this, we will get m4 equal to 4.1 kg. Hence, mass of the sample after 4 days will be 4.1 kg. Okay, friends. So in this lecture, we have discussed one important problem of mathematics. Okay, thank you.